Hello, I'm Ross Hamilton. I'm a system architect here at OnLogic, and it's a pleasure to be with you today at this Edge Field Day event. If you are just tuning in, this is session 2 of 2 that I am going through around our products and kind of where they fit into different places. Please take a look and go back and take a look at the first session if you get a chance. As a quick reminder, OnLogic makes hardware that is aligned to these 4 primary product categories. Our industrial computers are intended to be highly configurable, long life, and very easily deployed. They kind of act as that entry point for the industrial space. Our rugged computers take that up a notch. They share a lot of the same characteristics with our industrial platforms, but they support additional extreme temperatures, shock and vibration, digital I/O support, and they are really great for systems that need to be in motion. Our panel PCs are ultra responsive. They are ruggedized, and they really give you direct control over all of your operations. Our edge servers pack an incredible punch, and they provide the flexibility and the ability for you to manage your data at scale. So specifically, they are focused kind of in the on-premises edge, and they bring a lot of additional functions that you might not otherwise find in typical servers, such as features of intrusion detection, tamper-proofing, etc. Now, in our first session, we talked about how OnLogic views the edge, not necessarily just as a technological construct, but really as a tangible place. And this tangible place has a lot of unique, complex challenges and diversity in these environments. In the first session where we talked about our products in these different places, we explored a modern farm. We talked about a mining facility that is north of the polar circle. And in each one of those places, we discussed how some of OnLogic's products and platforms really can be incredibly impactful in these environments. In this session, we're going to continue exploring 2 additional places about where OnLogic lives and what platforms can be leveraged. Okay, so let's visit a steel mill. And if you watch some of the introduction around the founding of our company, you heard Lisa briefly mentioning this company, Steel Dynamics. Now, the interior of a steel mill is a punishing environment. It's got roaring furnaces. I wouldn't want to be this guy that is standing up there with all of that hot molten material within close proximity. There is dust everywhere. Temperatures can get to unbearable heights, and there's probably a lot of debris and thick grime that coats on top of everything. Now, this can be a formidable challenge for any type of technology, and specifically edge computing devices in particular. Now, any type of delicate electronic is going to have a hard time surviving this level of intense heat. Sensitive sensors might be rendered useless in this environment. But we really need to think about, though, how do we optimize efficiency within these types of environments? How do we increase reliability? How do we reduce downtime in this type of environment? Now, you have to push the boundaries of what is possible in terms of technological resilience to really think about how you can solve those problems. So looking at edge computing in terms of steel production, why is it important, right? And really it's about playing a positive role relative to infrastructure development, relative to resource conservation, relative to economic growth, and relative to safety and sustainability. So let's take a look at one of the products that would be incredibly impactful for this environment. And for that, we're going to look at our Tacton TC 401 panel PC. This particular product has a lot of special features that are going to be really well suited to survive and thrive in this type of environment. It provides an easy-to-use touch interface that allows you to manage and handle complex machinery. When workers are able to quickly identify problems, they're able to access key bits of information that is presented to them in a very clear, easy-to-use methodology. And they're able to kind of look at these complex systems in their manufacturing facility with a lot greater ease than going and looking up a manual. They've got some type of tangible display that's there at the edge, and they can interface directly with it. Now, does anyone know why it's called a panel PC?
They have a touchscreen panel in the front of them usually?
That is the answer that a lot of people would come to. And the reality is, though, the reason why it's called a panel PC is not necessarily because it's a touch panel, but because they're typically installed in industrial control panels.
Yeah.
So if you're on some type of industrial control panel that is working the motors that are dumping the slag off into, the next pit or what have you, that is where this type of device would be. So there's a lot of cool things as a result of that. And you can kind of see to that point of saying, hey, that this device is usually mounted in some type of enclosure because there's a lip that goes around all of these devices. So usually what happens is that the screen is on the outside of the system or outside of that control panel, and the other guts and stuff is on the inside. Now, our devices have a lot of ruggedization such that if you really wanted to, you can put them on a Visa mount, you can access them directly, you can put them on a flexible arm and be able to touch and interface with it, okay? Now, in terms of some of the resilience here, yes, this is the kind of device that if you're in this type of environment, you need the fanless design for some of the reliability. You need the wide operating temperature. You need the rugged construction. And let's also say that you might have in this type of environment a lot of forklifts or other equipment that's moving around. You might even have some of this facility that might be outdoors, and you might need to have these in some type of outdoor environment. So within this particular product line, we have different displays that are UV resistant, so they have additional UV coatings on them. They have higher brightness levels, so we've got standard brightness and high brightness levels that allow you to be able to see it whether it's indoors or outdoors. And we've got additional really cool features like proximity detection and cameras that can be optionally added to these different devices, such that if you wanted to say, hey, I need to know when the worker is going up and interfacing with this machine, I need to identify who it is and make sure that when they enter in certain amounts of information, it's the right information, or I've got a log or I've got a record of what that information is. So some really cool things.
So this one, the
Yeah.
temperature range is -20 to -70 to 70.
Yeah.
Now your other ones were from -40.
-40.
What's the difference?
The big difference.
What is it?
The big difference is generally relative to the industrial panel, right? That's the Achilles heel here. So the panels themselves, for the most part, to be able to kind of say, hey, within the line of a product series, there's a few outliers that exist in the industrial panel space, but for the most part, the -20 to -70 is kind of within the confines of what is typical within the industry.
So you couldn't put it outside in that mine in Sweden.
What was that?
You couldn't put it in there outside in that mine in Sweden.
Yeah, it would be a little tough to say, hey, I want to put this in Sweden and work on it there. If you were in a little bit maybe regulated environment, it would be better. You would be taking some risks if you knew it could get down to -40. Yeah.
Is the screen itself, can it be used just for monitoring with some kind of
Yes.
external input?
So that is another key point that I want to get to. So along with the launch of this product where we have basically an all-in-one, which is an integrated kind of Intel 12th gen processor, we have the ability to say, hey, you want to buy one of these? Our platform, the TN101, is a non-compute platform. So it just has a display input and a USB input in any one of our computers. So long as you can do a display port output and you can take a USB cable into it, you can convert and operate a touch panel monitor with any one of our computers.
Is it just DisplayPort?
Just DisplayPort, yes.
So I was actually going to go down that line is, looking at that picture and we all see, 12th gen and very modern computing, but a lot of industrial stuff is very old. It's things like RS-232.
Yeah.
How do you hang on for those things?
Yeah, exactly. So We do offer, so within this particular platform, we heard a lot of folks saying, hey, we got a lot of legacy protocols. We've got a lot of functionality that needs to just, we can't change that out, right? And so we have our mod bay platform in here. So this little area that you see here, that is a mod bay expansion. And it is a little mezzanine form factor card that brings up the necessary, high-speed signaling buses. And then we've got our mod bays that support legacy protocols, legacy capabilities, additional COM expansion, right? So if you want RS-232, 422, 485, being able to support that capability.
Yeah, I like also the capability to replace, to use the panel. A lot of older industrial computers had glass tubes that
Yeah,
no longer work, or,
Right.
completely burned in, so you need to replace them.
yeah. So we're really excited about this particular platform. It is proven to be quite interesting. There's some other really unique features and capabilities that we've added to it. Quirky little things like intrusion detection. So if someone opens the panel that the thing is mounted into, you could detect that and then say, hey, I'm going to shut it off or go into a notification mode, right? So other cool little things there. Okay.
Ross, on a slight tangent,
Mhm.
this device that turned up on my desk here has a whole lot of digital I/O
DIO.
ports,
Yeah.
which suggests to me that you need an SDK in order to be developing applications for it. Do you mind hitting you may have it somewhere else, and maybe just completely out of
Yes.
left field, but I need some tools to build good applications with this. What do you provide?
Absolutely. So the device that you have in hand, just for everybody that is viewing live or will be viewing later, that is one of our Factor series. It's the FR202. It is based on an industrial grade Raspberry Pi, and all of the DIO expansion that you're seeing on that effectively is part of a carrier card that we are attaching that CM4 SOM on. And so you have all the native capabilities that would be part of like Raspbian or the functionality that is integrated with the Raspberry Pi based Ubuntu distribution.
So as a Python developer, I'm
Correct.
using exactly the same libraries I would have used on any other
Yes.
Pi.
Yep.
Although, of course, on this one's an x86, and again, that's
Yes.
digital I/O
So
at the end as well.
that one, I believe, is a RS-232 that is coming out of that.
Yeah,
So
that's
it's a, yes. And that you were holding, just for everybody's reference, is one of our CL platforms, probably our CL250. Okay.
So I have a question
Yes.
related to power.
Yes.
Been noticing that some of the environments that you're trying to run these in may not have what would be necessarily the cleanest
Absolutely.
power coming to it.
Yes.
I've actually been in a scenario where I've had built a data center in the back of a semi,
Yeah.
and it ran off the diesel engine.
Yep.
And we had to scrub the power to ensure that everything ran, because you've got some sensitive equipment in
Correct.
there as far as that's concerned. Are you doing something on the boards or doing something else to ensure that that's
Yes.
the cleanest variety of power coming to the device?
Yeah. So relative to that question, so for example, you'll notice on this chart here, I have two notions here: 12 to 24 volt input power or 12 to 48 volt input power. Now, this platform, we've modularized the power circuitry, because you can have a lower cost optimization if you have a cleaner power source input. And let's say you wanted to do just within that 12 to 24 volt range, and you've got a cleaner input source, you can provide that, and it's a lower cost power module that comes with it. The alternative is that we support kind of this 12 to 48 volt ruggedized power input module that allows you to kind of go within the slop and has additional rugged power protection. So that includes things a little bit over voltage, under voltage spikes that happen transiently. So when you've got a little bit more noise in the power lines, we are taking that and cleaning it down to a nice clean voltage signal as it goes into the system through the power module.
Okay.
And you can find that a lot of wherever we say we're 9 to 48 volt or 12 to 48 volt, particularly in our rugged space, we offer that. Because the panel PC, we were trying to look at, hey, we need a lot of ruggedized features in this, but we also want to have some cost optimizations for folks that say, hey, I just need this indoors, and I have a regulated environment, and I have clean power. what could I do here to help cost optimize that and not have to have a blanket slate, completely different product line. Okay. Okay. All right. And this is the last place that we're going to visit. So we're going to think about a smart building in New York City. Now, is anyone here from kind of the Northeast region? So Michigan all the way to New York City? Show of hands. One. Few. Vermont probably counts in this scenario. Okay. I know that Steven's from the Ohio area. So raise your hand back there. Yeah. Yeah. So so back in 2003, for anybody that lives in that area, there was a series of cascading events, right, that really caused a catastrophic power failure. Apparently, there were some small fires in the Ohio region, and they wreaked havoc on the national grid. I can remember being at home in Michigan, and the power just boom shut out, and it was shut out everywhere, and everything was done. No cell phone signals, no nothing. And I remember being home alone by myself thinking, how do I get the generator working? I was quite a bit younger at the time. Now, as this outage spread, Con Ed in New York City recognized that it was coming, but they only had about a 30-second window before, some level of, okay, this is going to happen before power was completely out within the city, that they could have done anything relative to it. Now it's a little window, and obviously back in 2003, there wasn't much that was going to be done as a result of it. So what ended up happening is a lot of people were stuck in elevators for hours and hours until eventually the power was able to come back on in the dark with strangers, having to have a good time. So now, one of our customers, Nantum, is saying, hey, how could we do a smart building solution that really could identify this type of imminent power failure? Not only that, but what other types of analytics and information could we gather that we could apply the same type of logic to say, hey, what if this happened? What could we do proactively? And one of the thoughts here, elaborating on the elevator scenario, is if you had a little bit more time and you could take some action against it, you could have moved all the elevators to an adjacent floor, opened the doors, and then people wouldn't have been stuck in elevators for hours, right? There really could have been a cool application for edge computing back in 2003, could it have been there, okay? Now, Nantum was like, hey, how do I take all this operational technology and start thinking about it from a perspective of gathering all this analytics so that we could take these smart actions? But to gather all this information, they needed to say, how do I gather all this? How do I have a reliable piece of hardware that can sit in some of the mechanical spaces of buildings, like this lovely mechanical space that you see on the right of the chart? That's a pretty clean mechanical space, if I do say so myself here. I have to imagine that a lot of places and basements in New York City don't quite look that nice. But they needed a gateway device that they could take and gather all this information and then start gathering it and be able to pull it back up to an intelligent dashboard to make smart choices for building automation. And one of the platforms that is really good at where this could strive is our Helix platform. So when we look at Helix, this is designed for being able to support some of that ruggedized capability in terms of it's got nice, no moving parts within the platform. It reduces the risk of any type of throttling that could occur due to a single point of failure, like a system fan. Any type of particulates or any type of dust, it would be resistant to if it was in one of those mechanical spaces in the basement of New York. It's got some extended temperature. If the air conditioning was to go out within the facility, it would be able to survive and sustain within that ecosystem. It's got all of the necessary, solid state components that are within the platform. No spinning platters within hard drives. no moving components. So it's solid state construction, and it's built on some of our hard shell technologies. So all of the components that require any type of heat sinking are being directly heat sunk to this silver heat sink that you see that's on top of our platforms.
So that's 0 degrees to 50 degrees. So what is determining the temperature operating range in different?
A lot of times that is the component selection that we pick with the platform, right? So there are a variety of different components, component grades, right, that exist. And this is everything from basic USB controllers, network controllers, et cetera, that live within the confines of this. We have kind of extended temp, which is really the 0 to 50 range. It goes a little bit beyond what you otherwise might find in commercial. And then you go to the wide temperature space, right? The wide temperature is where you get to kind of into the negative temperature ranges all the way up into the upper 70s and pluses.
Because basements in New York City must drop below 0 degrees in winter.
Perhaps. I think it probably depends. And if that's the case, then in those scenarios, we would probably be looking at saying, hey, might want to use one of the carbon platforms for that particular use case. Yeah. But it really all comes down to the component selection that we do within the platform. And with that component selection, as we get more extended temperature range support, additional cost, et cetera. Okay.
Do you have power backup? How do you guys handle that? Typical batteries?
Yeah, so a lot of the times these types of devices will be installed in small enclosures, little NEMA enclosures, et cetera. Within those enclosures tend to be DC power supplies, and then within those enclosures as well, if you're looking for some type of battery backup, it would also be kind of fit within that enclosure. So you say, okay, what's my power draw relative to this unit on average? How long do I need it to stay up? Let's make sure that we get the right UPS that can be maybe DIN rail mounted or adjacent to this platform that can be there with it. Okay. Or conversely, if you're not using that type of application where you're putting it into some type of NEMA enclosure, okay, yeah, maybe it's just mounted, wall mounted, and you've got another UPS that's sitting adjacent to it. Yeah. The other thing that I want to call out, right? So we have our Helix 600, which can support additional GPU PCI expansion. Our Helix 610, which adds the ability to support redundant hot swap solid state drives, and that brings in additional storage should you need it within this particular platform. All of these devices in our Helix series support both Wi-Fi and cellular connectivity for additional connections to the outside world. Okay.
Cycling back on the power question, it strikes me that these are designed to be in a scenario where you're going to be on some sort of reticulated power, or you're going to have some local generation. These are not optimized for sort of battery solar deployments in any of these models.
It's entirely plausible that you could connect and leverage them to some type of solar scenario. In that case, it would probably be advantageous to look at using some of our carbon platforms for that, depending on how clean the power was. Sure. Not to say that you couldn't use some of our platforms here that are lined up and oriented with typical 12 to 24. It just depends on how clean you can.
That's a range I can easily get out of solar panels into some
right
accumulator batteries.
Yeah, exactly.
Charge control, but yeah, that's not a. It's an external solution, the same as the power protection is an external solution. That's not
Correct.
Something you focus on.
Correct. We've candidly looked into, hey, how could we be creative here and do something along these lines? But ultimately, it's kind of, well, do we really want to try and define that for folks, or can we say, hey, there's a lot of flexibility, there's a lot of options. If we're being prescriptive to one, it makes it more complex. And yes, what works for you might not work for you.
But in those scenarios where you've got the MCU built on its separate power rail, that would be an ideal situation for, we may have transient power.
Right.
We're going to do a graceful recovery when the power is stable.
Correct. And that's really one of the scenarios where the MCU can be valuable. We can monitor some of the external circuitry, we could turn it on. And again, that's maybe a use case where some of the carbon platforms would come in more handy because they have that additional MCU control, whereas that's a little bit of a delineation against our Helix line. We don't include that. So any of the digital I/O or the additional, COM expansion for these platforms is all effectively based off the host operating system. Okay. Any last questions? All right. So, to our audience in the room, thank you very much. Appreciate everybody here on the panel for all your delightful questions. Appreciate it. To those of us online, thank you. This is the end of the second session. Thank you for visiting these different additional places with us and kind of looking at how our products fit within this scope. And where our products can be used. So please be sure to check back and look at the entirety of OnLogic's presentation from Edge Field Day as it pertains to the origin story, the previous session where we looked at additional places and where our products fit, and where our partners and how we interface and connect with our partners. So thank you very much. And please be sure to check out OnLogic.